Hello there, welcome back. This is the first of two review videos for the atom. So, on the atom practice test, this video will go over about the first half of the unit, material-wise, and the second video will finish off the rest of the questions. So the questions go in order, but we are going to do some skipping around. So let's jump into this. Number 4 says, what is the mass number of this? Now, if you're looking at your periodic table, that top number is your mass number, and that bottom number is your atomic number. So, mass number has to be 19. That's it. But if we're going to look at this in a little bit more detail, the mass number is the number of protons plus the number of neutrons, and the atomic number tells you the number of protons always. Now, if an atom is neutral, it tells us the number of electrons. But if you see the word atom, atom means that it is neutral. Now, up to this point, we haven't talked about anything other than neutral atoms. So protons equals electrons. Okay. Number 5 says each diagram below represents the nucleus of a different atom. Which diagram represents nuclei of the same element? So, same element means you need to have the same number of protons. And so if we look at this, we have two pictures of D, which is pretty cool. So D has 1 proton, E has 1 proton, Q has 1 proton, but R has 2 protons. So R cannot be the same element because it has a different number of protons. So D, E, and Q are the only acceptable answers here. Now, the difference between D, E, and Q is the number of neutrons. So if you have the same element, so same number of protons, but you have a different mass, which means you have a different number of neutrons, that is the definition of an isotope. Same element, but a different mass. And in order to keep the same element, but change the mass, you can only change the number of neutrons. But again, same element, same protons, D, E, and Q. Next, number 7 says, what is the mass number of a carbon atom that contains 6 protons, 8 neutrons, and 6 electrons? So, again, mass number is the number of protons plus the number of neutrons. So if you have 6 protons and 8 neutrons, you get 6 plus 8, which is pretty basic math, and you get 14. Boom, your answer is C. That is it. Number 9 says the number of protons and neutrons in each of 4 different atoms are shown in the table below. Which 2 atoms represent isotopes of the same element? So if we look at A has 8 protons, D has 9, E has 9, G has 10. So hey, D and E have the same number of protons, and that's what makes it the same element. And the only thing that's different is the number of neutrons, and again, that's what an isotope is. Same element because you have the same number of protons, but the number of neutrons are different, so the mass is different. So our answer here has to be E and D because the number of protons are the same. Okay, number 11 says the table below gives the masses of 2 different subatomic particles found in an atom. Which of the subatomic particles are each paired with the corresponding name? So if we think about the particle and the relative mass, we have proton, we have a neutron, and we have an electron. So when scientists were studying this, they noticed that the proton was really, really tiny, and they're like, yeah, I don't want to deal with that number. Let's create a new number, and let's call that 1 AMU, or 1 atomic mass unit. And then when they weighed the neutron, they're like, oh, well, it's basically the same thing as basically the same mass as the proton. So let's also call that 1 AMU. And then by the time they measured the electrons were so much smaller compared to the proton and the neutron, they're like, let's just ignore it and call it 0 AMU. So this part you should know. If we look at this question though, it says, well, we know X and Z are different masses, so it can't be B and it can't be C, because D's a possibility right now. If it was protons and neutrons, they would have the same mass. But now it's like we're down between protons and electrons. And the question now is, well, which one of these is an electron? Which one is a proton? And if we look right here, this is a much smaller number. So the smaller particle of mass is your electron. So that means Z has to be the electron, and that is what A says. Okay, number 13 says, which statement describes the location of two types of subatomic particles in a helium atom? So here you should just, before we even look at the answers, let's draw a picture of an atom. So we have positive things, which are your protons. We have neutral things, which are neutrons. And together, your protons and neutrons form the nucleus. And then you have, let's do green, your negative electrons outside in your electron cloud. So based on that picture, the only answer that makes sense is A, protons and neutrons are located inside the nucleus. So it helps if you could draw yourself this little picture so you know what is what. Number 15 says, which statement describes the structure of an atom? Again, this goes right back to the picture. So you have protons, neutrons, electrons, just like that. And so it can't be A because electrons are not positive. The nucleus doesn't contain negative protons. Protons are positive. Now we're left between C and D. But the answer has to be C because the nucleus has a positive charge. If we look at the nucleus, we have protons, which are positive, and neutrons, which are neutral. So neutrons don't bring any charge at all. The only actual charge that's there is positive, so the nucleus is positive. And then you have these negative electrons that are circling around in their cloud, so that's what makes the answer C. Okay. Number 17 says an experiment in which alpha particles were used to bombard thin sheets of gold foil led to the conclusion that an atom is composed of. So this is the gold foil experiment by Ernest Rutherford, and this is super, super important. So if most of the particles passed right through, they didn't hit anything, they went straight ahead. So if you're not hitting anything, that means the atom has to be mostly empty space. So that means we can get rid of C and we can get rid of D. Now, every so often, this positive alpha particle, so he knew the alpha particles were positive going into this. So the positive alpha particle got repelled off of something and went a different way. Now, in order for something positive to be repelled, the thing that it's being repelled off of also has to be positive. And that meant that you had a small, dense, positive nucleus somewhere within the atom. So the conclusions of the Rutherford gold foil experiment: atom is mostly empty space with a small, dense, positive nucleus. Okay. Number 18 says atom of O16, O17, and O18 have the same number of. So these are all the same element. And if you're the same element, you have the same number of protons. But the thing that's different is, you have a different mass, but you're the same element. So that means you are an isotope because you have a different number of neutrons. So you have the same protons, different neutrons, so you have the same number of protons, so you can get rid of A and D, but a different number of neutrons. That's what gives you the different mass, the different neutrons. Remember, electrons, we haven't changed them yet, and their mass is so tiny we can ignore it, so changing the electrons does not change the mass. That's what an isotope is, though. It's same element, so same number of protons, different mass because the number of neutrons changed. Okay. Lastly, number 25. 25 says, iodine has many isotopes, but only iodine-127 is stable and is formed in nature. One radioactive isotope, iodine isotope, iodine-108, decays by alpha particle emission. Iodine-131 is also radioactive and has many important medical uses. So, guess what? Who cares? The question says determine the number of neutrons in an atom of iodine-127. So right here is your mass. And that, remember that your mass number is the number of protons plus the number of neutrons. Now, if we want to find the number of neutrons, we have to first figure out how many protons you have. So iodine right now has the mass of 127. If you look at your periodic table, 53, that is your atomic number. Remember, that is your number of protons. So if you wanted to find the number of neutrons equals the mass number minus the atomic number. So you're left with number of neutrons is 127 minus 53. So if you do 127 minus 53, you get 74 neutrons, and that is it. You do need to remember this little equation to calculate the number of neutrons. Protons, you can just look at the atomic number. Electrons, for right now, will be the same as the number of protons because the atom is neutral. Neutrons, though, you have to do that little equation. So that is it. Hopefully this helped. And then the next video, which will come eventually, will go over the other part of the test. Bye.